Guys, hope all of us are doing fine. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome each and every one of us into our discussion for today. And we're going to look at an aspect of basically polar coordinates. And this is going to be assisting us try to do evaluation of multiplication and division of complex numbers in this specific video or the subsequent videos. And this culminates from the previous discussion which we looked at a representation of a complex number in terms of a phasor set, which was given in terms of the x component and the y component with an imaginary unit given in terms of this specific representation. And we had said that basically this imaginary unit is going to be representing the root of -1 given as such. So in a sense, we had said that if we have the x and y axis given using this specific representation, we can represent this specific, of course, magnitude of this specific component which we had given in terms of a phasor z, and this can be given in terms of this specific, of course, a sum of the two, of course, components given for x and y. And we had said that for us to represent this in terms of this diagram, we're going to have these two axes for the real axis, which is going to be given in terms of the real axis of the phasor z, and of course the imaginary axis of the phasor z given as such. And this specific representation formed what we refer to as the Argand diagram. Now in this specific case, I'm going to look at this specific aspect using the normal representation which we normally do for the Cartesian coordinate system. And for x and y, we're going to have this particular section of this particular magnitude of this phasor which we had given in terms of r, which is of course given as so we're going to have this one from the Pythagoras theorem given as such, and this is going to be representing, of course, the square of x plus the square of y given as such. And we have decided that if we are going to consider this specific aspect, then therefore we shall have this one given in terms of y and x, and we're going to have this specific diagram referred to as the Argand diagram. Now, this particular representation in terms of x and y is analogous to a representation of a point which we can give, for instance, for p. Now, suppose this specific representation was given as p, then therefore we can have this one represented as x and y coordinates. Now, we can conveniently represent this specific point using what we refer to as a polar form, which is going to be a different way of having these specific coordinates of perhaps the phasor set represented in another way. So we can have this one from a previous discussion on the concept of trigonometric ratios. We're going to see that if we consider this as x-axis, then therefore we're going to see that this O0 is going to be forming our origin. And if a point we have this specific point is given as such, we are going to of course find the position of this specific point by its representation of the coordinates of x and y. Now, in a sense, they said that using the trigonometric ratios, we can identify the angle theta which has been subscribed between this x-axis and this specific, of course, position or the distance from this point, which is given by this specific component of r. And this can be given in terms of this specific representation for the sine over this particular angle theta. So we said this specific angle is given as opposite over the hypotenuse, which basically is y all over r given as such. So this implies that we're going to have this specific component given in terms of y is equivalent to r the sine over theta. And then we're going to have the component of the cosine over theta given as adjacent, which is x all over the hypotenuse given as basically r. So in a sense, we are going to have as well this component over x represented by the function over the r at the cosine over theta given as such. So in this case, if we try to look at this specific, of course, representation for the coordinates, then we can have p in a way represented using this specific aspect of r and the theta. And this case for the particular components of x and y, we're going to have the respective of course coordinates over r, which is going to be forming our x for r cosine over theta, and then r the sine over theta given as such. And this is going to be in a way representing this specific aspect of the point p. So this particular representation in terms of this, of course, distance for r and the angle subscribed is referred to as a polar or representation of these specific coordinates. And we're going to see that basically for the polar representation, this specific coordinates is going to be giving us a convenient way of trying to, of course, have this particular set of angles represented. And in this case, if we have a point P, which I've just elaborated on, and this distance R, then we're going to have an angle theta given as such. So if this is going to be, of course, identified from the origin, and this particular axis is going to be the x-axis in this specific direction, just as I've shown, then we can see that we can represent this point using the, of course, a reference over this particular origin, which we can give in terms of either origin or what we refer to as a pole. And therefore, this is going to be giving us the implication of a polar coordinates given as such. And the angle which we have given as theta, of course, I've said that this is going to be the angle through which the baseline of our OX is going to be, of course, rotated in order to align with this particular angle of OP. And that is going to be forming the angle theta given above. Now we're going to have a set of values which are going to be multiples of 2 pi, which is basically going to be, of course, equivalent to this 360 degrees, which we are going to be using as our, of course, values which are going to be formed by this specific angle subscribed by theta, which I've just shown on the board. Now we're going to see that this particular r, which is I've said is basically the distance, of course, from a fixed point P with reference to the origin. This can be given as a function of theta, as we have just shown in this specific case from this particular reference for the two basic trigonometric functions. And this is going to be assisting us in trying to represent various forms of angles in terms of polar coordinates. Now, from our previous discussion on the concept of course, functions of compound angles, and in this particular discussion, I hope then, therefore, that if we come across a multiplication or division of our complex numbers being represented in such a kind of a form, or perhaps forming some kind of functions of compound angles, then we're in a position to do the same evaluation appropriately. So check our description boxes for various links of other videos, engage us in the comment section, and also ring that notification bell to get updates on our various discussion in math and sciences. So that is it for now, guys. Bye, God bless you. Catch us in our next video.